right, so now we're going to do 37 and maybe till about 42. So 37 you see here, it's basically the same thing that we did in the non-calculator section, except that you're allowed to use your calculator. So here we have the arc sine of negative 2/3, which is your value for pi. So you're going to do everything. It's a two-step equation, and then you would just press arc sine in your calculator. Now in this section, because we're looking for the degree, make sure that your calculator is in degree mode. So pay attention to that. Now there are two answers usually that are found, but I'm not sure where they're finding them. They're probably using coterminals or something. But this answer would be okay with me if you were doing this for me on a test. This section right here, when you put in, this is factoring. I found two numbers that add up to 7 and multiply to give me 6. And I found out that it was 6 and 1, and then I put 3 twice, reduced one of them, and got sine of theta plus 2 and 3 sine theta plus 1. Set them equal to 0, and there was really no place on, there's nowhere in the unit circle or anywhere that sine would be, the theta, that the arc sine would be -2, because you know that your domain goes from -1 to 1. Remember earlier in another video. But there is a time when arc sine can be -1/3, and you do get an answer of -19.4. But we're going to use the coterminal angles here to really figure out what the real answer is, because it has to be between 0 and 360, and we get 340.5. Now your answer key gives 2 answers. Not sure where they got the other answer, but one answer here is fine with me. Alright, now we're on to the Unit 3 section, but this is Chapter 5. So this is how many triangles are possible. The formula is if A is less than B sine A, there's no triangles. If A is equal to B sine A, there's 1 triangle. And if A is greater than B sine A, there's 2 triangles. Unfortunately, this formula will not be given to you, so please memorize that. For this entire section, please make sure that you are in degree mode. So from now on, for the rest of the packet, you should be in degree mode. So when we do this, 40 times sine of 20 does give you 13.7. A is 10, and 10 is less than that. So this is not an equal sign, this is like a blank. So basically 10 is less than that, so we have no triangles possible. Alright, always set up your triangle. So I set up my triangle here, and I found out based on the information they gave me, it's ASA, so I'm going to use law of sines. So I was able to find the last angle because, you know, they gave me 2 angles. So I use my law of sines. It's written backwards from what the packet gives you, but you still get the same answer. And make sure if they tell you to go to 3 decimal places, that you are to 3 decimal places. And make sure that you are in degree mode. Alright, I'll let you take a moment to write that down. Alright, so here they said what's the measure of B? We are going to use a mixture of law of sines and law of cosines. Because they gave us 3 sides, we are using the law of cosines. And this is the law of cosines that's given to you, so this is given to you in the packet. So basically you just follow all the steps, and then at the very end, since we are looking for an angle, you're going to use arc cosine. In the other example, we did not use arc sine, we only use regular sine because we were given 2 angles. But here we're looking for the angle, so you use arc cosine, and you see that it's 98.3 degrees. So because that is the value for C, and I'm really looking for the value for B, I'm going to use the law of sines to get my value for B. And this right here is all of the information that will help you get B. So I'll give you an opportunity to write that out. All right, here's 41, my favorite, ambiguous case. So you know with the ambiguous case that you are going to have two chances of getting either 0 triangles, 1 triangle, or 2 triangles. So when you do the ambiguous case, you see here that when we set it up, that we have 58, and they gave us 11.4 and 12.8. You always write it twice because we have a possibility of 2 triangles. Remember that. So when I do the whole law of sines, I get 72.2 for B. But remember, you have to do the supplement of B. Yes, and this is the ASS case. You have to do the supplement. You have to do the supplement of what you find. Not the supplement of what you're given, but what you find. So I had the supplement of B, which gave me 107.8. Now I'm just going to add these two together and subtract by 180, and I get 49.8. Here I'm going to add these two together, subtract from 180, and I get 14.2. So because I was able to get 3 angles for both triangles, I have 2 triangles. But you know, a triangle's not complete unless you have 3 angles and 3 sides. So here I use the law of sines again to find my value for C1, which is this one, and C2, which is this one. All right, so basically I'll give you a moment to write all this out. All right, 42 starts our SOHCAHTOA section, which is my favorite because it's so easy. From a point 200 feet from its base, you have your angle of elevation. And angle of elevation is always here. If they talk about angle of depression, you draw it up here, but it's always going to wind up being alternate interior to that anyway, so it's the same thing almost. So how tall is the lighthouse? Set it up, and pretty much they want you to stay 3 places after the decimal, so that's why that's the answer. Okay, last question for this section is 43. So a truck is traveling down a mountain, so you have your truck, and it's traveling down the mountain. So it's going at 5,280 feet, so that's what you put here. And then it has an angle of elevation of only 7. So they want to know what's your answer for how high has the truck fallen. If it were to fall from here to here, how high has it fallen? And then you do your SOHCAHTOA using O and H, which is opposite over hypotenuse. And this is what you get. All right, that concludes this video. So in honor of, that's for the ambiguous case.
Now make that mother
Go stupid. Ha, okay. That's for the ambiguous case. Get it? Dance, dance, but instead of dance. Okay, good luck, everybody.